There are almost no similarities between Earth and Jupiter. Ours is a sweet, small planet with plants and cute pandas. Jupiter is a giant gas horror with furious hurricanes which never subside. And if you fall into this planet, you might literally fly through it. But what would happen if our Earth was the size of the father of the solar system? Oh, this is going to be fun. Jupiter is a planet so big that I bet you can't even imagine its scale. Its radius is about 11 times the radius of Earth, and it's about 316 times more massive. So, to turn Earth into another Jupiter, we'd need to increase its radius by 11 times. If the planet's density remained the same, then the mass of our new Earth would increase greatly. Actually, it'd be as much as 4 times larger than Jupiter's. Of course, these changes wouldn't go smoothly. The very first thing that we would immediately notice, nope, not the size, gravity. It would increase by about 11 times compared to old Earth's. Scientists say we can actually survive on a planet with greater gravity, but only if it's less than 5 times stronger than what we have now. Well, let's assume that we're daredevils, always ready to challenge nature. What would our life be like? Well, not very pleasant. After each step, you'd have to sit down on a bench and take a break, as if you've just run a marathon. Yes, it would be that hard to walk. Oh, and good luck with getting up later. In order to somehow move around this planet, we'd have to pump up very strong muscles. No more problems with junk food, 'cause you'd have to become a heavy lifter just to get to the refrigerator. The force of gravity affects not only movement, but also the size of everything. Do you know that many astronauts gain some height due to weightlessness in space? So if you're worried about being short, here's a solution for you. On the other hand, strong gravity would make us all shorter. This would go not only for humans, but for everything on our planet. Trees would become very small. To grow upward, they would have to move water from their roots to branches, which would be unrealistic with such gravity. So they'd all turn into little bushes. Also, no more mountains. Even the largest ones would become very small. But at least now, everyone would be able to conquer Everest. This would also apply to animals. Our pets would have to quickly evolve into pumped-up corgis just to be able to walk somehow. Oh, and say goodbye to birds, of course. If you think that's not enough suffering, let's add another thing. It would be very difficult for us to breathe. Atmospheric pressure would increase dramatically. That's because Earth would start to pull air toward itself with great force. You'd literally feel the weight of it on your shoulders. Remember what I said about taking a break after each step? Now, imagine that you'd also have to breathe through a pillow. Yeah. And that's not all. Atmospheric pressure plays an important role in the behavior of water molecules. It would be much more difficult for water to boil or turn into ice. Most icebergs would melt, and it's possible that we'd have no more clouds too. All water vapor would come crashing down on us in giant torrents of rain. We'd be lucky if we didn't get flooded instantly. But, oddly enough, there would also be some advantages. For example, everything around us would become much more spacious. Assuming we didn't get flooded, there would even be a bunch of deserted areas on the planet. Maybe land prices would finally fall. But these unexplored areas would most likely remain unexplored, since we'd hardly be able to travel across seas and oceans. Not only because moving across the water would be incredibly difficult, but also because all water bodies on the planet would become 10 times larger. The very thought of getting lost in the ocean is frightening, but imagine if it was 10 times deeper and bigger? Uh-oh. So, no more sailing. And forget about flying by plane, or visiting space ever again. But it seems like it's still not all. If Earth was the size of Jupiter, we'd also have volcanoes raging everywhere. Due to the increase in its mass, Earth would become terribly unstable. All extinct volcanoes would become active again, and there would be lava and poisonous gases everywhere. In 1883, there was the most destructive eruption in the history of humankind, the eruption of the Krakatoa volcano. It occurred on one small island, but people all over the planet could feel the consequences. The eruption destroyed the island, triggered many tsunamis, and clouds of poisonous gases spread for miles. Now imagine this, but 10 times worse. That's what would happen on our Jupiter-sized Earth. It would probably be similar to the fall of the Chicxulub meteorite, the one that wiped dinosaurs off the face of the Earth. Then, poisonous gases spread all over the planet, causing one of the greatest massive extinctions in the history of Earth. Oh, and we would also lose the magnetic field, like the cherry on top of the cake. The magnetic field is very important for life on Earth. According to Rory Barnes from the University of Washington, it shields life on the planet from the nastiness of space, which means all sorts of radiation and solar winds. There's a molten iron core inside our planet that is responsible for producing the magnetic field. If the amount of pressure on this core increased due to gravity, it could solidify. And because of this, Earth's magnetic field would disappear. We would be exposed to the effects of cosmic radiation. Too scary to even imagine. Alright, so now we know that living on this new Earth would be a real nightmare. But what about outer space? You've probably heard that Jupiter, thanks to its strong gravity, protects us from asteroids. Well, this would become our job. Jupiter experiences about 24,000 collisions a year, and now it'd be our destiny. Do you remember me mentioning the Chicxulub meteorite? Similar tragedies happen to our planet once every 100 million years or so. But if it became the size of Jupiter, these guys would visit us every Friday. Also, we'd have to say bye-bye to the moon. Our natural satellite is too close to us. So if Earth grew in size, it would be a real catastrophe. We would literally watch the moon being torn apart in the sky. Of course, after that, all these fragments would crash into us. One of the theories claims that billions of years ago, the moon somehow separated from Earth, and its pieces gathered into a ball. Now, it would be like watching its creation rewind. And even if the moon survived, somehow remaining in Earth's orbit, the changes in the tides would still be dramatic. The consequences of these changes would be very unpredictable, but probably a bunch of tsunamis would be some of them. On the other hand, we'd probably gain a couple of new moons. Jupiter has as many as 79 of them. It would probably be a spectacular view, if only gas clouds from all those volcanic eruptions didn't block it. Also, the appearance of a second giant planet would have significant consequences for the whole solar system. Don't worry, other planets wouldn't crash into us. Many people underestimate just how far the planets are from one another. But still, the new Earth would shift the orbits of other planets a little and affect the rotation speed. And Earth itself would rotate around the Sun much more slowly because of its huge mass. For example, 1 year equals 12 Earth years on Jupiter. All this, of course, would greatly affect seasons and the climate in general. So, would there be life on Earth? Bold of you to even ask this question. But if one day we do manage to find a habitable super-Earth close to Jupiter in size, it would be very interesting to take a look at it.
Extremely hot and insanely fast. Yeah, that's me. Oh wait, you mean the space thing. Okay, first, they discovered Peg 51, an exoplanet that orbits a star similar to ours. An exoplanet is any planet outside of our solar system that orbits a star that's not the Sun. This planet was completely different from anything we've ever found. Almost the same diameter as Jupiter, but half the gas giant's mass. It took only 4 days for this exoplanet to orbit its star, which seemed impossible. It was definitely too fast for something so massive. And then, scientists started finding something they've named hot Jupiters all over space. Lots of heated gas giants were located only a couple of million miles away from their stars. Sometimes there were a couple of space bodies orbiting their stars pretty closely, and many were a few times bigger than Earth. Solar systems where they found hot Jupiters are not like ours. We have a neat system with smaller rocky planets on the inside and big gas giants on the outside, and almost all of them peacefully orbit the Sun, following their trajectories. Everything is in order. When a star is at the earliest stage of its formation, it creates a disk of gases, debris, and dust surrounding it. It's called an accretion disk. These gases slowly get pulled into the star because of its gravitational forces, and this leads to some kind of a stellar whirlpool. The outer parts of the disk are more gas-dense than the center. With time, the whirlpool effect gets even stronger. The same thing happens with hot Jupiters, which causes these gas giants to start orbiting much faster than usual. This also carries it further toward the star in a tightening spiral. Luckily, our Jupiter didn't become a hot Jupiter. Our gas giant started its life as an icy Earth-sized asteroid, which is different from the way hot Jupiters form. During the time when it was forming, Jupiter was around 4 times as far from the Sun as it is today, somewhere between Uranus and Neptune. About 2 to 3 million years after Jupiter first formed in the accretion disk of our Sun, it started a 700 million year long phase astronomers call the Grand Tack. Now, tack is something a boat performs when going towards a buoy and then slipping past and around it. Then it speeds up and goes in the direction where it came from. That was the same thing Jupiter started doing, and in its tightening orbital migrations, the planet's gravity could have moved many asteroids and other space bodies, distorted the orbits of larger planets, and caused collisions and chaos. Jupiter's Grand Tack would have destroyed many big space bodies. It's a could-have-been scenario, but luckily, Jupiter changed its course and became a peaceful gas giant. Neptune, Uranus, and Saturn were starting their own version of this chaotic process. Saturn even got so big that its gravity started pulling Jupiter away from its orbit. But after some time, these gas giants' orbits became locked. Then both of them managed to clear away the gases remaining between them. And since these gases were some sort of fuel for the planet's migrations, Jupiter and Saturn could both finally settle into the stable orbits we know today. Jupiter can still lob 1 to 2 icy asteroids at the inner planets from time to time. But when our planet was younger, this could have been one of the processes that formed the oceans on Earth. But Jupiter is much calmer these days. Saturn's gravitational forces have moderated the situation and are now keeping it under control. Now, Jupiter is our protector. It's 2.5 times the mass of the other planets of our solar system combined. It's some sort of a gravitational shield orbiting around the inner part of the solar system. Jupiter redirects incoming debris and asteroids away from the inner planets, Mercury, Venus, Earth, and Mars, keeping us all safe. Because of this, Earth has always been protected, so our planet has had enough time to evolve complex life forms. And it hasn't been destroyed by asteroids, hot Jupiters, or other space bodies. Jupiter wasn't the only planet that could have collided with Earth. Scientists think Mercury might have been involved in a hit-and-run accident with our planet. Mercury is the innermost planet in our solar system. It's the closest to the Sun and the smallest planet out there. And it also keeps getting smaller. Nowadays, its diameter is around 9 miles smaller compared to its size 4 billion years ago. Scientists think this might be happening because the planet's core is made of iron, and this iron is cooling and becoming solid, which is slowly reducing the planet's size. Mercury is the planet with the biggest number of craters in our solar system. Its atmosphere is really thin, so it can do nothing to keep the planet protected from meteors. The largest crater on Mercury's surface is at least 963 miles across. It could fit Western Europe from Germany to Portugal. The object that formed such a crater must have been at least 62 miles long. With all these craters, Mercury looks similar to our Moon. It orbits the Sun faster than the other planets, so 1 year on Mercury lasts around 88 Earth days. That means celebrating a birthday every 3 months or even more often. At the same time, the planet rotates so slowly that a day on Mercury lasts almost 59 Earth days, a long time to wait to go to bed. There's a piece of Mercury on our planet. In 2012, a green meteorite was found at a street market in Morocco. Scientists studied its composition and concluded it could be from Mercury. Mercury doesn't have its own moons because of its small size and weak gravity. Plus, the planet is too close to the Sun. By the way, the only other planet without moons in our solar system is Venus. Mercury has a really thin crust, like a good pizza. One of the theories of the planet's formation claims there was a major collision where the planet lost most of its crust. It could have also moved Mercury from its original spot. It wouldn't be unusual. The gas giants in our solar system also didn't form in the location where they are today. Mercury also has an eccentric orbit, which means it could have been kicked out of its old orbit and moved to a new one. Scientists also think Mercury might have collided with the early Earth. One theory says that's how the Moon could be formed, out of all the material flying away after the big crash. There might even have been pieces of Mercury's crust in the mix. Exoplanets Kepler 107b and Kepler 107c are a pair of planets that orbit a star similar to our Sun in the Kepler 107 system. It's around 1,700 light-years away from us. These planets have almost identical sizes, both with a radius 1.5 times that of Earth. But one of them, Kepler 107c, is almost 3 times as dense as the other. That's because the planets have a different composition. Some scientists believe that Kepler 107b is less dense because it probably collided with another unknown planet in the past. This powerful hit took away part of its surface and left behind a very dense core rich in iron. A huge comet hit Neptune around 200 years ago, but since Neptune isn't a rocky planet with a thin atmosphere like Mars or Mercury, it's harder to find evidence of this impact. But a comet called Shoemaker-Levy 9 broke apart in 1994 and smashed into Jupiter. Astronomers managed to record this event. It helped them learn more about the elements and molecules the collisions left in Jupiter's atmosphere. This information helps scientists realize that the amount of carbon monoxide in the upper layers of Neptune's atmosphere is higher than in the lower ones. This means a big comet likely hit the planet in the past, since comets have carbon monoxide in their icy tails. Something huge slammed into Uranus, too, changing the planet forever. A space object twice bigger than Earth hit the ice giant. This left the planet tilted, and it looks as if it's rotating on its side. Uranus is extremely cold, way colder than it's supposed to be. It might mean that the object that slammed into it was probably a young protoplanet made up of ice and rocks. Also, some of the debris from that collision may have created a thin shell around Uranus. It still traps the heat coming from the core of the planet. There are strange energy pulses bombarding our entire galaxy, and they come from the other side of the universe. Over the last decade, scientists have been observing bizarre flashes of light coming toward our planet. This phenomenon is called fast radio bursts, or FRBs. These signals travel through a couple of billion light-years of dust and gas. That's a rather long way. So far, no one has figured out what's going on behind these bursts.
You shouldn't have made that bet with your friends. Now, your spaceship is hovering just over the atmosphere of Jupiter, a gas giant and the largest planet in our solar system. You're staring at the ginormous pale yellow sphere in front of your eyes, dreading your task, which is to fly through the planet and leave on the other side. Doubts are plaguing your mind. Is it even possible? Well, you're about to find out. Jupiter is truly massive. If the planet was 80 times as massive as it is now, it would have a chance to turn into a tiny red dwarf star. But even though its size isn't enough for such a transformation, Jupiter is still huge, more than 89,000 miles wide at the equator. The planet is so large it could fit inside 1,300 Earths. It's also impressively hot, about 43,000 F at the core. If you decided to parachute into Jupiter, you would never land on a firm surface because the planet mostly consists of gas. Around 90% of the planet's atmosphere is hydrogen. The remaining 10% is made up of helium with tiny traces of other gases. The planet is also surrounded by a layer of thick brown, yellow, red, and white clouds. They make Jupiter look colorful and beautifully striped. There's no solid ground on the planet. That's why astronomers define the planet's surface as the point where the atmospheric pressure equals that on Earth. You wouldn't be able to stand on that surface, though. It's just another layer of gases. but the gravitational pull there is around 2.5 times more powerful than on our planet. The deeper you dive, the more difficult it gets to move. Under immense atmospheric pressure, hydrogen and helium gases turn into a dense fluid. Closer to the core, this liquid becomes a mixture of metallic hydrogen and helium, which makes this region as exotic as the surface of the sun. Now, to imagine the gigantic pressure that exists near the center of Jupiter, think of the deepest place in Earth's oceans, the Mariana Trench. It's nearly 7 miles deep, and pressures there reach more than 1,000 bars. For comparison, at sea level, you feel the pressure of approximately 1 bar. But that number doesn't seem all that impressive when you think about the pressure at the center of Jupiter. It reaches up to 1 million bars. So, if you tried to enter that region, your spacecraft wouldn't just get squished or melted. No, it would simply disintegrate into atoms. You won't even have time to say, "Oops!" If you still decided to take the plunge, you'd have to go through different parts of the gas giant. First, you'd see wispy ammonia clouds. You might even enjoy a brief period of blue skies, due to the same phenomenon of scattering of light that occurs on Earth. After that, you'd pass through some red-brown clouds. Those are made of ammonium hydrosulfide. And then you'd see intimidating towering clouds lit by constant lightning storms. Way deeper, between 4,350 and 8,700 miles down, your spacecraft would enter an atmosphere so hot that it would be glowing. This is where the temperature rises up to tens of thousands of degrees F, and the pressure rises to megabars. That's also where your spacecraft is likely to start to disintegrate. This is a mysterious region of Jupiter's interior we know little about. It's still unclear whether the planet's core is a molten ball of liquid or a solid rock more than a dozen times the mass of Earth. It's most likely the former. There's even some evidence the gas giant's core might be melting right at this moment. Scientists have suggested that it consists of a mixture of materials, including nitrogen, carbon, and even iron. In any case, not to risk your life, you'd better admit you've lost the bet and return to your hospitable home planet.
Sand is everywhere. In your eyes and mouth, in your hair, under your t-shirt, and in your shoes. You can hardly stand. The wind is so strong, it's knocking you down. Suddenly, an especially powerful gust sends you to the ground. You crawl toward the back door. It takes you a lot of effort just to pry it open. Once inside, you get to your feet and sneak a peek outside. Just clouds of dust and a deafening roar. Okay, it's time to call for help. It started a month ago. One day, you went out to the garden behind your house. It was a windy day. You even spotted a tiny tornado under your apple tree. It hardly reached your knee, lazily swirling around tree leaves and dust. You tried to make it disappear by poking it with your foot. But even after several attempts, the mini whirlwind just didn't want to break apart. You shrugged and went back home. The next day, the tornado was still there, and had it grown? Interestingly, instead of growing taller, it got wider. At that moment, it started munching on your flowering shrubs. You got curious and decided to keep track of this unusual phenomenon. You measured it every day and carefully wrote down all the information in a special notebook. Maybe later I'll write an article or even publish a book about my storm, you thought. One day, you got out of the house to find your favorite apple tree broken. You couldn't figure out how it happened. The storm still looked harmless and too weak to damage a rather large tree. But after this accident, you started asking yourself if not calling for help was the wrong thing to do. Apparently, it was, because just a month later, your mini-storm has suddenly grown to twice its original size. It's unsafe to go outside now. It seems as if your house is in the middle of a real tornado. You can't see the sky behind a wall of dust and debris. Your garden is ruined, trees broken, bushes and shrubs pulled out of the ground and sent flying somewhere far away. You hear your doorbell ring. A group of scientists you invited has come to the rescue. You show them the garden with your personal natural disaster and enjoy their stunned silence. But after a couple of seconds of initial shock, they spring into action. Ignoring the howling wind, they start carrying inside different equipment. It looks very complicated. Your kitchen turns into the researchers' laboratory. You get informed that your house will be temporarily used by the scientists. You take your things to the smallest bedroom and watch the professionals work. Your kitchen is filled with beeping gadgets and devices covered in flickering lights. People in protective suits and lab coats scurry around. Surprisingly, they don't bump into each other. Neither do they create traffic jams. You bring the notes you've been taking and hand them to an elderly man in a white lab coat. He thanks you as if you've just given him the gift of his dreams. The next several days pass in a flurry of activity. The storm in your garden is growing. The scientists seem to get gloomier every time you see them. It's around 2 a.m. when something wakes you up. You blink your eyes open and realize the house is shaking. Your homegrown tornado must have gotten so big, it's reached the house. In the morning, several scientists pull you aside to tell you the unpleasant news. You have to move out. The storm is indeed growing. Soon, it'll wipe your house off the face of the earth. Nothing can be done. You're gaping at the people telling you to get out of your house. Where will you go? They tell you they're building an additional research lab not far from the place. It's important to be able to observe the storm in real time. Anyway, there's a spare room with everything you may need in that facility. Why don't you stay there for a while? It would also be convenient for the scientists. They may need you to answer the questions that appear during the process. You agree because you don't have any other choice. The researchers help you transport your stuff to your new accommodation. You walk around your house, saying goodbye to your favorite coffee table, your sofa, and your cozy bed. The scientists tell you that there's no time to move your furniture to another place. The next day, you wake up to the news that your home is gone. The storm gulped it down at around 4 a.m. Over the next few weeks, the grown-up whirlwind has swallowed 2 houses of your neighbors, the nearby forest, several abandoned cars, and a small flower store. It's now so big, it's coming close to a large lake several miles away from the town. People get evacuated. The authorities have announced a state of emergency. One day, you notice that scientists are talking in hushed voices. They look even more worried than usual. You corner one of them and try to find out the truth. Soon the scientist spills it. The researchers have got some evidence that confirms their worst fears. According to all their estimates, the storm that once started as a tiny tornado in your garden is going to grow into another great red spot. Only on Earth. Crimson-colored clouds are spinning counterclockwise at an incredible speed. Beneath them, you can see vibrant hues of the largest planet in the solar system, the gas giant Jupiter. Those clouds are called the Great Red Spot. It's a colossal storm raging in the atmosphere of Jupiter. If you found yourself at the storm's center, the winds would be rather calm there. But on the edges, the storm's speed can reach 425 miles per hour. That's twice the speed of the fastest and most severe hurricanes on Earth. Over the decades, the size of the red spot has been changing. Right now, it's 1.3 times as wide as our planet. The storm's roots go as deep as 200 miles into the planet's atmosphere. The average tropical cyclone on Earth usually stretches for no more than 9 miles from the bottom of the storm to its top. The unique phenomenon on Jupiter has existed for so long because the planet doesn't have a solid surface. It consists of layers of clouds made up of vapor, water ice, and ammonia. Underneath, there might be an ocean of liquid hydrogen. Our planet is solid, and hurricanes slow down and break apart once they go low enough to touch the surface. But the Great Red Spot has nowhere to make landfall. That's why it keeps raging. The scientist also tells you the most bizarre and alarming thing about the storm in your garden. Instead of growing weak and disappearing many weeks ago, it's not only still going, but it's also getting bigger and more powerful. Even the most experienced specialists can't explain this phenomenon. After analyzing it for days on end, they've come to the conclusion that it shouldn't have appeared on Earth. It's against the laws of nature. Interestingly, the storm's composition is a bit similar to that of the Great Red Spot. You're impressed, but still can't get why the researchers look so worried. It turns out that your once mini-storm is likely to grow as large as that on Jupiter. But since Earth is way smaller than the colossal red spot, it's likely to swallow our planet whole. It'll grow and grow, wiping out towns and cities, forests and highways. At the same time, it'll become more powerful. People will have to leave their homes and get evacuated to relatively safe areas, until there are no more safe areas left. This process will take years, but it'll still be too fast for people to prepare. There will be two ways to deal with this global problem. One of them is to colonize the moon or another planet, for example, Mars. But it's an incredibly long process, and the storm will conquer the entire planet before the first spacecraft with people leaves Earth. Or scientists may try to stop the hurricane. There's a technology called the sunglasses effect. Billions of tons of dense gas get pumped into the atmosphere. This gas absorbs sunlight and cools down ocean water, which is the engine of any hurricane. The researchers aren't sure if this method will work with your storm. It formed not over the ocean, but in your garden.
When you explode planets, things get red hot. Atmospheres are pulled away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. But how can you do it? How can you blow up, let's say, Jupiter, the largest planet in our solar system? Thick brown, yellow, red, and white clouds hide its surface, making the planet look colorful and beautifully striped. First of all, we shouldn't forget that the gas giant's powerful gravity is holding it together, which is the reason for the planet's spherical shape. And we would need to add a lot of energy to blow it apart. But here's the problem. If we used some explosive material for our goal, it wouldn't be very efficient. A lot of energy would get radiated as heat in the process. The mass of Jupiter equals 318 Earth's masses and about 1,000th of the mass of the Sun. The gas giant's diameter is also more than 11 times greater than that of Earth. It would be around a quarter of the distance from Earth to the Moon. So, can you imagine the enormous binding energy that keeps Jupiter together? Now, experts claim that to explode this space giant, you'd need a pile of nuclear explosives as heavy as 4 moons. Can you imagine it? Or let's take another unit. A highly explosive material known as TNT. How much of it would you need to blow up Jupiter? The answer is 50 megatons. And 1 megaton is 1,000,000 tons of TNT. These are some huge numbers. They also mean that if you made Jupiter out of TNT and blew it up, the explosion wouldn't produce enough energy to blow the planet itself apart. It would puff up more and more. But gravity would still manage to pull all the stuff Jupiter is made of back together. But let's suppose you somehow managed to find an enormous amount of explosives that would be enough to get rid of Jupiter. You hit the button, sitting in your spacecraft, hovering over the giant planet. Something is going on down there on Jupiter, but it's unlike anything that would happen to a rocky planet. Instead of chunks of solid crust, you see jet streams of gas accelerating away from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away into space turns liquid. That's hydrogen in its different form. Under immense atmospheric pressure, this gas becomes liquid closer to the center of the planet. A bit later, you notice that the liquid becomes different again. Now, it's a mixture of metallic hydrogen and helium. And finally, something solid. It might be Jupiter's core, which is 14 to 18 times the mass of Earth. The blast lasts no more than half a second. And still, the explosion is millions of times brighter than the sunshine. It's so powerful, it evaporates smaller planets like Mars and Earth. The sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. How would the disappearance of Jupiter affect our solar system? For one thing, this gas giant shepherds the asteroid belt. And without Jupiter out there, the belt might grow unstable. It would lead to an increase in the amount of debris invading the inner solar system. Plus, the gas giant also acts as a sponge, absorbing rogue chunks of rock and not letting them enter the inner solar system. So, it's great that Jupiter is practically indestructible, Unless it collides with an object as huge as the Sun, of course. Or you could probably scoop the planet up a bit at a time. It would certainly take a while. One hypothetical project called a Jupiter brain suggests taking Jupiter apart and turning it into a planet-sized supercomputer. And you know what? Some advanced technological civilization could probably do it, but not us humans yet.
Jupiter's gravity shattered a huge comet. It wasn't enough for the space monster. A real catastrophe happened. The shards didn't fly in different directions. They lined up and rushed towards Jupiter like the rail cars of a train. 21 fragments up to 1 mile in diameter burst through Jupiter's atmosphere. Fireballs at the speed of 37 miles per second bombarded the planet's shell. They heated the space around them to 50,000 degrees Fahrenheit. That's higher than the temperature in the Sun's upper atmosphere and 312 times hotter than you need to boil an egg. Well, I'm not hungry anymore. The impact was like from a rock falling into a pond. The meteorite fragments formed giant plumes on the surface of Jupiter. Substances from its lower atmosphere rushed upwards. The process generated a tremendous amount of energy. Overheated streams of fire shot into the stratosphere. The monsters left behind them glowing plumes 1,900 miles long. That's greater than the distance between New York and Texas. Dark bruises appeared at the side of the blows. They were about the size of the Earth. Comet Shoemaker-Levy 9 was the name of the violator of Jupiter's boundaries. The collision of celestial bodies happened in July 1994. It was a scientific sensation. For the first time in human history, a catastrophe of this magnitude was observed. The attack raised an important question for astronomers. Why is Jupiter unlucky? Space monsters attack it thousands of times more often than the Earth or any other planet in the solar system. All right, let's see. You decide to board a starship and travel to the mysterious Jupiter. A space probe would need 2 years to get there, but your starship is faster. You'll be there in… Great, the journey only took a second. Jupiter is actually big. It could fit 1,300 Earth-sized planets in it. It looks beautiful thanks to gas clouds. This planet has no solid surface, but there's a strange stain on its surface. It looks like a huge eye that can fit 3.5 Earths. This storm will scare anyone. It's 10 times higher than Everest, and the wind rushes at a speed of 300 miles per hour. It's been going on for 350 years. You wouldn't hide from such a storm in a car, so it's good you're in the starship. If all the planets of the solar system merged into one superplanet, the new object would still be 2.5 times smaller than Jupiter. Large size also affects gravity. Spacecraft use Jupiter as a springboard to jump. The giant's gravity increases their flight speed and helps them reach their target faster. Gravity has turned the planet into a magnet for comets, asteroids, and dangerous space debris. Jupiter is a true space superhero. Its gravity shield takes a hit and deflects space monsters that fly into the inner solar system. The dinosaurs don't agree, but more on that a little bit later. What if Jupiter was swallowed up by a giant vacuum cleaner tomorrow? I can only say one thing: we'd have huge problems. Without a giant shield, thousands of comets and asteroids are attacking the planet much more often. Most of them burn up in the atmosphere or aren't large enough to affect us. But there are also larger comets and asteroids. After their collision with the Earth, you can say goodbye to all life on the planet. For example, in 2009, a celestial body crashed into Jupiter. It left a bruise the size of the Pacific Ocean. It's scary to think what traces it would leave on our planet. Most likely, the Earth would turn into a fireball. But recent research from astronomers suggests that Jupiter isn't such a nice guy. On the contrary, it's a bad guy with a slingshot that shoots comets at the Earth. A physicist used computer simulations. He found that Jupiter is equally likely to deflect and send comets toward the Earth. The giant attracts potentially dangerous objects and only partially protects us. It's already tried to knock out our planet many times. 66 million years ago, a cosmic body 10 miles in size crashed into the Earth. The energy of the impact set the surface of the planet on fire. It caused a huge earthquake and tsunami. A fiery rain fell from the sky on the Earth. There were millions of tons of debris and dust in the atmosphere. They stopped the sun's rays from reaching the planet. The nuclear winter began. This disaster led to the extinction of the dinosaurs. Scientists have named this space criminal Chicxulub impactor. Computer simulations of scientists at Harvard University showed where it came from. Chicxulub wasn't an asteroid, but a comet. This means that the core of its body wasn't stone and metal, but ice, dust, and frozen gas. It resembled a dirty snowball flying through space. The meteorite wasn't going to set fire to the Earth, but Jupiter intervened in the plan. It threw comets in our direction. In 1770, Lexell's comet appeared near the Earth. Our planet and this object were separated by only 1.4 million miles, close to nothing in space terms. Lexell's comet came closer to Earth than any other comet in human history. The object could have stopped life on Earth. The comet flew too close to Jupiter. The giant caught it and sent it in our direction. Now, this isn't a very good move for a superhero that protects the solar system. After 3 years, the comet went past us. It flew 2 times around the Sun and returned to Jupiter like a boomerang. This time, the giant pushed the comet out of the solar system. But let's not blame Jupiter. Scientists believe that without this gas giant, life on Earth would most likely never have happened. Jupiter sent meteorites toward Earth, which carried organic molecules and water with them. They were the building blocks from which earthly life began. Nobody knows if comets would come with a valuable cargo without Jupiter and its dangerous gravity. If you fly away from Earth to the center of the solar system, you'll see the Sun. 8 planets are flying around this star. There's a belt of more than 1 million asteroids between Mars and Jupiter. One theory says there was only the Sun at the very beginning of the solar system's existence. Clouds of stone and dust surrounded the star. These particles attracted each other and formed planets over millions of years. Jupiter didn't want any new neighbors. Its powerful gravity prevented rocks and dust from uniting into planets. They remained asteroids and gathered in a belt inside the solar system. If today all the asteroids merged into one planet, we'd get a cosmic body that would weigh only 4% of the mass of the Moon. Previously, the belt was densely populated, but Jupiter's gravity threw 99% of the asteroids to other places in space. Jupiter isn't the only one that plays a role in the development of life on Earth. Our main assistant is the Moon. It's the only natural satellite of the Earth. Jupiter has 79 satellites, and every year there are more and more of them. Jupiter is also surrounded by rings, but they aren't as beautiful as Saturn's and are practically invisible. The rings are composed of small black particles. This is the dust that the meteorites eject into space after colliding with the moons of Jupiter. The Moon is responsible for the ebb and flow of the ocean. It regulates the life of bees, fish, birds, and amphibians. Even you feel the influence of the Moon every day. Changing the brightness of the disk in the night sky regulates the level of melatonin in your brain. This hormone is responsible for circadian rhythms, which are important for healthy sleep. The Moon came about thanks to another catastrophe, like many other things in space. Millions of years ago, the Earth looked like a ball of hot lava. There was no water or air. It was enveloped only in carbon dioxide and nitrogen. At this time, another planet the size of modern Mars crashed into the Earth. Scientists named it Theia. At a speed of 8,900 miles per hour, it collided with the Earth. The impact of incredible force threw millions of tons of material into space. The debris gathered into a ball that became known as the Moon. Scientists have almost solved the mystery of the Moon, but they don't know if there's a solid core in the middle of Jupiter or if it's dense hot soup that hangs in space. Jupiter has the largest ocean in the solar system. It's made of liquid hydrogen, not water. If Jupiter were 80 times more massive, it would turn into a bright star. Jupiter is a unique place that will never be home to humans. The pressure inside the planet is 2 million times greater than on the surface of the Earth. Extreme pressure and temperature would ruin any spacecraft that's gone too far. I guess that means Jupiter would have a crush on you.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
Jupiter, the fastest spinning planet in our solar system, with a day lasting only 10 hours. The biggest planet in our solar system, a gas giant more than 300 times as massive as Earth. It has rings of dust in colorful bands stretching across its surface, which are actually gases. And then there's the Great Red Spot, iconic raging storm, huge hurricane, 2 to 3 times as wide as the whole Earth. It's also insanely deep and goes around 300 miles into Jupiter's atmosphere. That's 40 times as deep as the Mariana Trench, the deepest oceanic spot on Earth. Way more extensive than scientists expected. Researchers have speculated about the Great Red Spot for hundreds of years already. This storm is circling Jupiter in its southern hemisphere. At the center of this giant spinning storm, the winds are relatively calm. On the edges, wind speeds go up to 425 miles per hour. That's twice as faster than the strongest hurricanes on our planet, 175 miles per hour. When there's a hurricane on Earth, it goes wild at first, but eventually starts to slow down. It finally breaks apart when it reaches solid land. Jupiter has a sky that's 44 miles deep. There are layers of clouds, and beneath them, scientists believe, lies an ocean of liquid hydrogen. The planet's core is supposed to be right under that ocean, but we're still not sure what exactly it's made of. As far as we know, Jupiter is a gas world, so there's no solid ground that would stop the storm. That's why the spot continues to rage on and on. Scientists realize the storm is constantly changing its size. Compared to data from 1850, it's shrinking right now. The Great Red Spot used to be 3 times the size of Earth. It's been a long time since it last got bigger. As it's shrinking, the storm gets taller and changes color into an intense orange, possibly because of the chemical reactions. New matter raises from the bottom of the storm. The red Great Spot could continue shrinking and eventually disappear in the next 10 to 20 years. But there could be another similar storm emerging somewhere else on Jupiter, if the red Great Spot ever ends. This storm might seem very deep, but it's still shallower than the giant jets of wind that rage around it and power the storm even more. Jupiter's bands of wind go to depths of 2,000 miles below its cloud tops. Jupiter is generally known for having crazy windy conditions in the upper and lower parts of the atmosphere. The middle part is called the stratosphere, and we didn't know what was going on there. Scientists usually measure wind power by watching clouds, and there are no clouds in the stratosphere. But when a comet, Shoemaker-Levy 9, collided with Jupiter in 1994, scientists got a chance to study cometary structure and composition and its effects on Jupiter's atmosphere. They discovered insanely strong winds in the stratosphere with speeds of 900 miles per hour. Jupiter isn't the only planet in our solar system with crazy weather. Mars has the biggest dust storms amongst all 8 planets. When such a storm is raging, it seems like it creates a blanket over the entire planet that lasts for months. One theory that tries to explain why dust storms are so big on Mars says airborne particles of dust absorb sunlight and warm the planet's atmosphere. This creates warm pockets of air. They start flowing toward colder areas, which then generates winds. These winds lift dust off the ground, which heats the atmosphere, makes winds stronger, and kicks up more dust. Mars generally has a very thin atmosphere. It mostly consists of carbon dioxide, and the volume of gases in the Martian atmosphere is less than 1% of that of our planet. But Mars used to be much wetter and warmer than it is today. That means its atmosphere was much thicker. A long time ago, it created a strong greenhouse effect and trapped the sunlight. Mars used to have a pretty strong magnetic field. Just like on Earth, the magnetic field on Mars was created by currents of molten metals in its core. But unlike our planet, the inside of Mars cooled enough to switch off the magnetic field. Without it, Mars wasn't protected from the solar wind. That's a powerful stream of particles flowing from our sun. It took only a couple of 100 million years, which is not much in space terms, for the solar wind to strip away most of the atmosphere on Mars. It went quickly because the sun used to rotate much faster at its earlier stages, so the solar wind was more powerful and energetic. And that's how Mars turned from a planet with a warm, wet climate into the cold, dry place it is today. Mars also has some interesting glaciers. They've been on its surface for hundreds of millions of years and can tell us secrets of the planet's past. For instance, that's how we found out Mars went through 6 to 20 separate ice ages during the past 300 to 800 million years. Satellites took images of 60,000 rocks of different sizes. They were distributed across the entire planet at random. If Mars had a single, long ice age, we'd find a progression of bigger to smaller rocks because they erode as time goes by. But the rocks were spread in clear bands of debris across the surface of these glaciers. Each band marked a different flow of ice, which means each of them formed during a different ice age. These glaciers are like time capsules because they could have all kinds of gases, rocks, or even microbes trapped inside. That means they could help us understand the changes in climate on Mars and tell us if there used to be any form of life on the planet. And the best thing, we don't need to drill deep down below the crust to find that out. Everything's on the surface. If you could go back in time, let's say 4 billion years, and visit the red planet, you'd probably see chaotic scenes of flooding. Scientists believe that megaflood happened because of a huge meteoritic impact. Because of the heat from that impact, ice on the planet's surface started melting. This flood carved out big ripples and waves in the sedimentary rock. Some wave-shaped features are over 30 feet high and spaced out 450 feet apart. Saturn also has its own unique weather conditions. Lightning bolts there can be 10,000 times more powerful than the ones we have on Earth. NASA's Cassini spacecraft was orbiting Saturn from 2004 to 2017. It captured lightning so strong and intense, we could see it even during the daytime. Cassini also recorded the sounds of those intense storms discharged into the planet's atmosphere. From time to time, Saturn has giant storms that go over 190,000 miles across the surface. They encircle nearly the entire planet. On Saturn's North Pole, there's a massive hexagon of clouds. It's a vortex of a pretty unusual shape that circulates hundreds of miles above the clouds and extends deep into the planet. But Saturn has its peaceful side too. Along with Jupiter, Uranus, and Neptune, it has its own beautiful auroras from time to time. All 4 planets have an atmosphere dominated by hydrogen. That's why you can only see these auroras in ultraviolet wavelengths. These northern lights are especially bright at dusk and right before midnight. Venus has a giant storm swirling in the atmosphere at its south pole. The vortex is as big as the entirety of Europe, and it's probably been there for a very long time. The atmosphere on Venus moves 60 times faster than the planet rotates. Venus is the hottest planet in our solar system. Even the rain there offers no relief, since it's sulfuric acid falling from clouds and evaporating before it even gets to the ground. The sun also has its own angry outbursts in the shape of powerful solar storms. These storms bring strong radiation and dust particles that can cause serious damage to satellites that track the sun's activity to let us know if something goes wrong. Every now and then, a crazy solar storm can catch us off guard. About 160 years ago, a strong solar flare caused severe issues in global telegraph communications. About 30 years ago, a solar flare left 6 million people without electricity for 9 hours. One theory says strong solar activity could have caused the sinking of the Titanic. It happened on the same night as a fascinating northern lights show. Some people believe a solar storm behind it had possibly disrupted the ship's communication systems and navigation, leading to one of the greatest unsolved mysteries ever.
What would happen if our planet turned into two separate ones, one consisting entirely of land and the other one of water? Could we survive on any of them, and how? Well, you're lucky, because I'm going to answer this question right now. So, let's imagine that our Earth has turned into two separate planets sharing one orbit. Let's call these hypothetical planets rock and water. I know, very original. Anyway, let's start with the rock, because this one is much easier to imagine. All we should do is ask, what would happen if all the oceans on the Earth suddenly dried up? Now, we know that water is life. It covers 70% of the surface of our planet. There's so much water that even if all the oceans and seas disappeared, some of it would still be left in underground rivers, streams, and so on. But unfortunately, it would not be enough for us to survive. All sea creatures disappear. After some time, all other animals, plants, and of course, people share their fate. Completely dried forests burst into flames sooner or later and burn until there is nothing left but ashes. But hey, it's not that bad. Well, it is bad, but life can still exist in some form. There are some bacteria that make cockroaches jealous. They're able to survive absolutely any conditions. For example, extremophiles have already evolved to live without water. These little guys can survive in an incredibly hot or acidic environment without water or even sunlight. Without them, the rock becomes an empty, lifeless planet. Although, who knows? Maybe someday extremophiles will be able to evolve into some wildly cool forms that can survive literally anywhere. But for now, the rock is just a floating rock, basically. Oh wait, did you imagine a hot desert or some sort of red-hot steppes? Surprise, surprise! This planet is actually extremely cold. You see, without water, there would be no atmosphere. The atmosphere consists of a concentration of various gases, including hydrogen and oxygen. Some H and O, you know where this is going, right? Yep, no water, no atmosphere. And since it is the atmosphere that accumulates all the heat we need, the planet would be very cold without it. The contrast between cold and less cold places also becomes very sharp. You see, water is basically a climate stabilizer. The oceans absorb almost all of the heat of our sun. They distribute it evenly over the Earth to make sure it doesn't get too cold or too hot. So without it, the rock gradually turns into a cold desert. The average temperature on this planet is around minus 100 degrees Fahrenheit. At both poles, the temperature is extremely low, about minus 300 degrees. And even in the warmest places, it doesn't exceed 20 degrees. These warm places are now the former oceans because their dried-up depths are located much closer to the hot core of the planet. Wait, I hope you don't imagine this planet as covered in snow either. We don't have any water at all, remember? It's just a very cold rock. At this point, we're just a bigger and browner version of the moon. The moon is basically a waterless piece of Earth, after all. But hey, what happens to volcanoes? They're basically our last hope to stay warm, aren't they? Unfortunately, volcanic activity is decreasing due to a lack of water. You see, volcanoes and their eruptions happen because of the collisions of two tectonic plates, the oceanic and continental ones. The weight of the water presses on the oceanic plates. They go under the continental plates and form volcanoes. So if there's no water weight, then there's no volcanoes and volcanic activity drops significantly. The rock now is just a planet full of many incredible high mountains. And every time the tectonic plates collide, they form more and more of these mountains and trenches, including some very big ones, like the famous Mariana Trench. I would say, be careful not to fall, but hey, there's no one to fall there. Also, there's no weather anymore. No water means no more snow, ice, or rain, or even clouds. The wind would probably be quite strong, though. Well, that's the fate of the planet rock. Not very bright, so let's just go see how the water planet is doing. Many, many billions of years ago, I wasn't around then, our Earth actually was a planet entirely covered with water. Then, about 1 billion years ago, the sea level dropped, the land appeared. This has changed the atmosphere of our planet forever, and that's how life was born here. But what happens if it returns to its original state? Well, to answer that question, we should first learn more about the ocean planets. So, what does one of these look like? Oh, sorry, I almost forgot. We have no idea. We haven't found any planets of this type because they're incredibly rare. I mean, there is one planet that is low-key and could be called an ocean planet. Yeah, I'm not even going to try and pronounce that. Still, even this one doesn't look the way you probably imagine. The water on it is in a very weird, unique state. Scientists have called this hot ice or superliquid water, and we've never seen anything like this before. In general, though, the actual ocean planets are very hard to find due to many physical reasons. These planets require very specific temperatures, pressures, and so on. But alright, just hypothetically, what would such a planet look like? Well, first of all, of course, it cannot be made entirely of water. I hope you didn't actually think that there could be just some gigantic water blob spinning around a star. It should still be a planet with a core and some kind of foundation. So let's just imagine that all the water on the former Earth has mixed into one giant salty ocean. Wow, that would be a dream come true for the sea creatures, but not for the rest of us. The only animals that could survive in this situation, except fish, are probably the birds that can swim and feed on fish. Now, I think even if the sea level rose significantly, at least a couple of islets could still stay above the water. Such islands would be the former peaks of huge mountains like Mount Everest. So if these birds build their nests there, they can even survive for some time. But what about you and me? Well, we still have a chance. If we had enough time to prepare for the huge flood, we could stay safe either in giant submarines or on giant ships. We can grow food on board and fish from the ocean. But without the Everest Islands, we are unlikely to last long. If something breaks and we have nowhere to dock, we won't be able to fix it. Unfortunately, we no longer have drinking water. Now we can get it only from rain or by filtering seawater. But we have to store it someplace, right? And all these water containers would take up a lot of space and be very heavy. But in general, planet water is not as bad as it might seem. It's quite warm. The average temperature here is about 50 degrees Fahrenheit. And the gap between the lowest and highest temperatures is minimal, from minus 20 degrees at the poles to 70 degrees at the equator. Compared to planet rock, this ain't bad at all. Planet water would also be slightly larger than the Earth in radius due to the volume of, yes, water. The density of this planet would be, on the contrary, quite low. The gravity could become a bit weaker, too. Now, as for both planets, if we place them in the Earth's orbit, after some time, they would still move away from each other and follow different trajectories. They would have aligned themselves not to collide with each other. On one of them, the year would last 12 months, and on the other one, 10 or 11. And that's about it. A fun fact. All of this can actually happen in the future. First of all, the Earth's crust is gradually becoming thinner. Hey, I like thin crust. On my pizza. On my planet, not so much. So, one day, water can really flood our entire land. On the other hand, in a couple of billion years, when our sun begins to expand and turn into a red giant, all the oceans on our planet will really dry up. Alright, take a deep breath and shake it out. That's enough of this grim fairy tale. It's a waste of time to worry about such things so far off when, today, I can't find my wallet anywhere. I thought I put it over here.